Hopefully it should be on. There we go, lovely. Okay, hopefully the stream should be on working. Let me have a check. Okay, cool, we should be good. Okay, so yeah, we are continuing with some GCSE revision. So yesterday we did the 2018 paper, and today we're going to do the 2019 paper. Again, this is paper one non-calculator. In preparation for the exams on Thursday with your non-calculator paper, and yeah, there's not much to say. I guess let's get started. Okay. So first question, a simple probability one. So it says there are only blue cubes, red cubes, and yellow cubes in a box. The table shows the probability of taking at random a blue cube from the box. Blue 0.2, red, yellow. The number of red cubes is the same as the number of yellow cubes. Okay. So what that is going to mean is that their probabilities are going to be the same, because the chance of taking a red cube is going to be the same as the chance of getting a yellow cube, because they're the same amount of each. Okay. So if we say the probability is P, P and P for yellow, red and yellow, we also know that all the probabilities must add up to 1, because these are all the possible outcomes you can have. So it has to be 1 for all of them. So then now we are just solving this this equation, right? So we know that 2p is going to be 0.8. That comes for 1, subtract 0.2 from both sides, and collect like terms, so p and p is 2p. And then p is simply going to be 0.4. So that means if we fill in the table, that means the probability of both of them is going to be 0.4 each. And you know this works because they're both the same and they both add up to 1. So that has to be right. Okay, so then it tells us there are 12 blue cubes in the box. Okay. Right, okay. So that's saying if we are okay, so if we are well, what does probability mean? That's only just generally, right? Probability of something is uh the probability how do I want to phrase this? Well, no, let's just say probability of picking blue, a blue cube. That's going to be number of blue cubes, right? Over total number of cubes, right? All there is. But we know that this is 0.2. And actually, it also tells us the number of blue cubes is 12. And so the total we can just call T. Okay. So then if you times by T, both sides, you get 0.2T is 12. Therefore, T is going to be 12 over 0.2. Okay. And obviously non-calculator, so you'd have to work this out. There are two ways you can do this. I think maybe the best way is scaling it, so get rid of the decimal, so you can times top and bottom by 10. So then you have 120 over 2. and then that gets rid of it. And then obviously 120 over 2 should be 60, right? That should be easy to compute. So actually the total number of cubes is going to be 60. Okay. And you can check this because then if you do 12 over 60, that should get you 0.2. And 0.2 is a fifth. So 12 goes into 65 times. So it's going to be 1 over 5, which is exactly 0.2. Okay, lovely stuff. Okay, so that's a fairly simplish-ish probability question to ease you in. Obviously, this is for high and foundation, but yeah, okay. So Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar, 2 times as much butter as sugar. Okay, so work out how much flour she needs. Okay, so there's 2 bits of information here. 50 grams of sugar equals 15 biscuits. But it tells us that he's making six. I don't know, she, he, I don't give a shit. They are making 60 biscuits. So actually, we need to scale this. So 60 biscuits equals some lots of sugar. Now, how do we get from 15 to 60 here? What we're going to times by? Well, 4, right? Because 15 goes into 64 times. And so you do the same here. So, times by 4. 50 times 4 is going to be 200 grams. So actually, what this is saying is, for all the 60 biscuits, he needs 200 grams of sugar. Now, we also be told that she needs 3 times as much flour as sugar. So, flour is going to be 3 times sugar. Right, if you write that mathematically. So she needs to put triple or times by 3 the amount of sugar she has. Well, actually, we know how much sugar she needs because we just worked out. So that's 200. So to work out how much flour, times it by 3, and therefore you get 600. That's what she'll need. Okay, so that's part A. Then she said she has to buy all the butter she needs. She has to buy all the butter she needs to make 60 biscuits. She buys the butter at 250-gram pack. How many packs? Okay, so similar process here. So firstly, it's a good idea to work out how much butter she needs because we told this as well. A very good note and exam tip, at least with Edexcel, but I assume it's every exam board, every paper you do, they will give you all the information you need, but also every piece of information is going to be relevant. So like every number or stat they give you is there for a reason. So you're gonna need in the question you're gonna have to make use of every piece of information most likely. So here we didn't use this in part A, 2 times butter sugar. But now it talks about butter in part B, so we're gonna need to use this line of information here. So anyway, we know in part A she has 200 sugar. So we also know from this butter it's gonna be 2 times sugar because she has 2 times as much. And actually, that's going to be again 2 times 200, which is 400 grams of butter. Okay. So this is a bit weird because this is not a hard one to calculate. So then, how many packs? Well, 250. 250 is 1 pack. So to get to 400, you're going to need to get to 400. It's not particularly clear what you timed by. So you could work that by saying 400 over 250. However, spot this. Spot that this is going to be 250. This is a way to spot this actually. So we know that 1 pack, let's reiterate, is 250. This is going to be a weird number to get between 250 to 400. It's going to be a decimal point, a decimal. Because it's a non-calculator, it's going to be quite tricky. Or you can work it out, obviously, but it's going to be a mess. But anyway, we know that one pack is 250 grams of butter. So therefore, two packs, if we then go down, because it's 500. And that's because we only have 400. She only needs 400. So we know she's not going to need many packs. So we can list it like this. Okay, but actually, 500 grams is plenty. So 500 grams is more than 400. So 2 packs is what she needs. So the answer is going to be 2. Bear in mind, it's not 1 and it's not 1.67 or something. It has to be a whole number. And obviously, if you can only buy whole number packs. And if you still have some butter left, you're going to need to just buy another pack, even though you're going to have some butter left over. I need to check that's right because I feel like 2 pack, that's not too much actually. Let me just check this. I'm a bit weirded out. I don't see anything wrong here. Could just be a weirdly worded question. I don't know. I feel like 250. I feel like the number's a bit high here. Is it 2 packs? Have I wrote a copy of the number down wrong or something? Um, no, 2 packs. Oh, okay. Okay, you didn't have to. Okay, there you are. 2 packs then. Yeah, I'm right. Then I expected the numbers to be a bit more harder than that. There you go. Anyway, that's to the wording. That's how you go about that question anyway. Okay, question 3. Quite a standard question. Highest common factor, 2 numbers. You can do this 2 ways. Now, the highest common factor is the factor that goes with the both 72 and 90. So if you do your factor tree here, 91, 45 and 2, 72, 72 and 1, 2 and what's it, 36, is it? Yes, however, you can do that and then you spot the highest number that is in both the trees. But the most effective well, it's only 2 marks. I feel like the most safest and effective way is actually doing the prime factor decomposition. So 72, compose it into factors. So it'd be it's going to be obviously 2 and 36. 36 is 6 and 6. And then 6 and 6 is 2 and 3. And 2 and 3. And at 90, it's going to be uh, 9 and 10. And that's 5 and 2. And 9 is 3, 3. So actually, 72 is, if we list them all, 2 times 2 times 2 times 3 times 3. And 90 is 3, oh, 2, let's put it in order. 2 times 3 times 3 times 5. And then the highest common factor is essentially the product of, well, look at the factors that are in both of them. So 2 is in both, so 2. Then you times 2, there's no more 2's here, so it's only in that one. 3, 3 and 3. And then there's another 3. And actually, and then 5 is on its own here, 1972. That's it, right? That's all the common factors. So the highest common factor, you just times it all together. So 2 times 3 is 6. 6 times 3 is 18. So the highest common factor here is going to be 18. That's a safe way of doing it without having to like mentally think of all the factors. That's, I feel like, a safer way of doing it. Might be a tad bit longer, but it's fine. But that's usually the method you want to do with this, I feel like. You can do it both ways, though. Eventually, to spot, if you did this, 18 is the highest number that goes into both of them. But yeah, that's the way I would approach that. Oh, great, more ones. If you recognise, there was a plan question um, in the last paper we did. So common themes, common topics. Perhaps there'll be some sort of sketch plan question in your paper, likely. Anyway, so the diagram shows the plan, front and side elevation of a shape on the centimetre grid. So it's the opposite way this time. So instead of them giving us the plan and no, giving us the shape and asking us to sketch the plan and all that. Now it's giving us the plan and all this, and it wants to sketch the shape. Now unfortunately, I'm not the best at this with shapes and I don't know, but we'll work through it. So let's see what's going on. So we look. If the plan is when we're looking down, okay. So if we look down on the shape, it's circular, and the front elevation. So that's when you're looking at it head on. So if you're staring at front of it, it looks like a rectangle. And the side elevation, when you look on its side. Uh, okay, this one I think you have to just recognise. I think now what. So the fact so a solid shape means it's going to be a 3D shape. So think about the 3D shapes that you know. And then also think about what 3D shapes on the top of it as a circular face, right? A circle. And actually, what actually it narrows down to a cylinder. So then essentially our job is to sketch a cylinder. And actually, the way I would perhaps draw this is like that, right? And actually, oh god, with a ruler. Um, there you go, roughly there. Obviously, they just want the gist of the shape, not exactly. But use rulers if you can. But it's a cylinder, right? And as you can see here, the front, if we start the front of it, it's rectangular like this. The side will be rectangular as well. And the plan, if we look on the other side at the back of the on the top of it or the bottom of it, it's a circle. And that's just one of those you need to know. So I think with these type of questions, usually it's going to be a 3D shape that you know. So solid shape means 3D. So then think about which of these matches to a 3D shape that you know. So here, there's not many 3D shapes that have a circle on the top of it, except for cylinder. I'm not sure there's others, but cylinder's the one that screams to me. But yeah, that's how to go about this. And also bear in mind the other part of the question, give the dimensions. So what does a cylinder have? Well, it has a radius and a height. So the radius is going to be, well, what's a radius, right? From the center, you measure from the center to the circumference, right? So here, obviously, it's going to be 2 centimeters here. So that's going to be 2. And the height, well, it's this, right? It's how tall the cylinder is. Well, that's corresponding to the edge of the front or the side elevation. So here, uh, well, how many squares? 1, 2, 3, 4, 5. So the height is going to be 5 centimeters. Uh, so then, yeah, you sketch. You could also include the diameter, perhaps, if you wanted to instead. So that'd be double the radius. So that'll be 4. I think that's the safest bet. I think. But as long as you make it clear. I think the best way to do this is to say, well, that's 4, and then down here is going to be 5. And you can even use the front elevation to confirm this. So this should be the diameter as well, right? If you think about it, the top of the if you imagine you continue the rectangle there, this should be the same as the diameter, right? And actually, it is because it's 4. 1, 2, 3, 4. If you do the little cross section bit, but yeah, that should be and that should be what they're after. There. So pay attention to dimensions as well. So what length of the shapes? So if the cylinder, it should have a radius and a height. Okay, for 2 marks, boy. But yeah, that's how to approach it. It's a bit tricky, I think, to explain this graphically. But hopefully they made some sort of sense. So that's my plan with this. Oh, pun intended, plan. The plan with these sort of questions, just recognize what 3D shape has the sort of shape of one of these things. So here, like the circle at the top, it's like a cylinder. Anyway, so that's how I'd go about that. Then question 5. Again, very, very similar to the other paper. There was another translation question like this, a reflection with transformations. Very, very similar. Again, like the same topics seem to come up. But here we have shape A is transformed to shape B. It's a transformation by a reflection in the x-axis, followed by a translation CD. So there's two things going on here. So firstly, it's a reflection in the x-axis. So what is the x-axis? So the x-axis is obviously this line here, the axis line here, and so we have to reflect it first of all. That's a good thing. Usually these questions, it gives you two transformations. Just do them bit by bit. Don't try to be clever and do it twice in one. Just make sure do it transformation by transformation. So here, reflection x-axis should reflect it. Coordinate 1, 2, 3. There you go. 1, 2, and then 1, 2, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then obviously draw the triangle. Actually, I might have a little. Let's test this. I think I might have a rule here. I'm not sure this will work well. Okay, let's see. Not sure if it'll work with the digital pen, but let's try it. So obviously then draw the triangle. Oh, here we are. And there we are, roughly there. It's a bit messy. Let's get rid of this little bit. Oh, got rid of the line. God damn it. Let's get rid of that. Oh God, it's even. I'm trying to use a ruler here. Uh, God, what am I doing? Okay, there we go. You know what? Sod the ruler. It's causing more stress. Draw a rough line there. God. Oh God. Obviously, do use a rule in the exam, but God, it's bloody awkward though on the computer. Oh, I don't know how people do it. God. Come on, I'm gonna do a bit better than that. There we are. Okay, roughly that. Obviously, it should all be straight lines, but roughly that's what you're looking at. That's the reflection. Then it says it's followed by then a translation by CD. So, um, try to map the vertices, the corners, onto this shape. So here, clear this coordinate here goes to this coordinate here. So look what's happening. So we go 1, 2, 3, 4, 5, 6. 6 left, and then we go 1 down. Likewise here, that should be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There we go. And then one down. And then here, 1, 2, 3, 4, 5, 6, and one down. So it's the same. So that means it's 6 down, left, 1 down. Now, as a vector, if you know, the vectors are basically, you almost treat them as x, y coordinates, really. So you can use like, if, um, there are ways you can obviously remember that left is negative, down is negative, right is positive, up is positive. But think about it, if you're going to the left, if you treat it like an x coordinate, if you're going to the left, you're going to the negative x side, right? So left has to be negative because you're going in the negative direction for x. So that's going to be -6. And one down's likewise. It's like the y. So you're going down the negative y axis. So that has to be -1. So down is negative, left is negative. If you then went right, well, you're going to the positive x side. Likewise, if you're going up, you're going up the positive y side. So that's how I like to remember. There are like ways that are like across the corridor, up the stairs, and all that sort of stuff. If that helps, that's great. But I think that's a more like, like I don't know. If you just treat this as x, y, but obviously you use the coordinates that look like this, but it's the same thing, but you just flip it essentially. And then if you think of it as x, y on the axis, well, x, if you're going left, it's negative. I don't know. That's how I think of it now. But obviously, it's up to how other people remember it. As long as you remember what neg signs, the directions are, then that's all that matters. But yeah, that should be the vector here. So once you transformed it in the x-axis, sorry, then that's the vector you move to shift the triangle onto there. Okay, that should be good. Again, a ratios question. Again, very, very similar. It's the same sort of topic, the same sort of working as the last paper we did. Very similar again. The shop sells pack of black pens, pack of red pens, and green pens. Again, there's three. It's a free variable, not free variable, a free pieces of information, 3-part ratio. Okay. So it tells us there are 2 pens in each pack of black pen. There are 5 and in red pens, 6 green pens in a pack. Yada. And it tells us how many packs were sold of each colour. So there's 2 different kind of ratios going on here. Let's have a look. So we're given that the total of 212 pens was sold. But we're told how the ratio of how many of these were sold. So actually, we can use the information to work at this. So, this ratio is telling us the ratio of the packs sold. So, 7, 3 to 4 packs sold. But remember, I did talk about this last stream. But with ratios, this is not the actual amounts of packs sold. This is just giving a ratio. If we wanted to find out how many packs were sold, the actual number of black pens, black packs of black, packs of red, packs of green individually, you can just times it by a number x. So then if you call it x, if you then scale this ratio by x, such that this is now the total amount of packs sold. So I don't know how to that's essentially what ratios are. It basically scales the true amount of, I don't know, packs sold to the simplified ratio. So obviously, because x is common in both of them, we can just divide by x. But actually, there is a hidden multiplier with ratios. And that's all you need to know. Ratios are the hidden multiplier that goes between the ratio and the true amount of something. You could also, I guess, draw like 7 boxes, 7 parts each of black, and then there's 3 other parts of red. and there's 4 other parts of green, and we know in total the parts have to be 212. No. 200, not 212. That's how many individual pens were sold. These are how many each pack. Okay, so this makes it a bit more complicated, but that's what the ratio is saying. That's what the X is as well. So each box is essentially X amounts. But yeah, um, that's the idea of the ratios here. But so then we want to we want to find the total amount of like packs or pens or whatever. Uh, okay. So we want to find the total amount of pens because that's what we're given here. But this tells how many packs of black pens are sold. So we know number. So if we want to find the number of black pens, not the pack of black pens, because remember this is packs. This is in packs. We want just the number of black pens individually. Well, we know the number of packs is 7x. Okay. Uh, but in each pack there were 2 pens. So each pack has 2, but there are 7x packs. So in total, the number of black pens is 14x. Okay, so then the number of blue pens, no, red pens now. There's no blues there. Red next. There we go. Red pens. Likewise, from this ratio here, we can call this. No, leave it there. From this ratio here, these are the total amount of packs sold for black, red, and green when we scale the ratio. Okay, this X, just to reiterate, ensures that this is the total amount, not the ratio, but the actual amount that we get by time. Okay, so so if we read this off, 3x is how many packs of red pens are sold, but each pack also has 5 pens. So this gives us how many individual pens there are, which is then 15x. And then therefore the number of green pens, again, there are 4x packs of green, but we're also told there are 6 pens per pack of green. So the number of green pens is going to be, let me move it over here away from the box here. Well, 6 times 4 is 24. And so these are now the number of pens of each colour. So that, but we also, so then we're told the number of all the pens is 212, and that's just going to be these all added together. And then we just do some simplifying. 24, 39, 53. Is that right? Should be. So then if you want to solve x, obviously then x is going to be 53. Uh, well, this is going to have to be a whole number. So 53 is going to have to go to 212. 1, 2, which it does because it's 4. Um, yes, 4 exactly. So that's x. But so now we can find how many packs of we can find all the information we have now because we know what x is, what the missing x is. But then it asks us to find the number of green pens, not green packs, but green pens, which is here, right? So therefore, number green pens is going to be 24 times 4, because obviously it's 24x normally, but we know x is 4, so it's 24 times 4, which is going to be 96, I believe. So that should be your answer. 96 pens. 96, lovely jubbly. So I think that's the key thing. I'll get rid of this now. I guess it's a bit confusing why it's there. And that's why I don't really like the box method because when ratio questions get a bit more complicated, I think it's a lot more. I know it seems a bit harder at first or complicated, but I think it really is more simpler to just scale it and just add an X there, and then this gives you the total amount. Okay, um, especially on higher tier anyway. I think that's the way I would approach ratio questions. Just if you want to scale, if you want to find the total, make sure you times by this X here to scale it between the simple. It's kind of like rate. It's kind of like well, it's exactly like fractions. Say if we had I don't know, a pizza slice of eight. One, uh, there we go. Oh, God, that's a rubbish one. Okay, but say uh, we had a pile pizza of eight slices, and you have six of them. So you have six out of eight. That is actually how many slices there were. But if you then simplify this, you get well, you don't get two, you get 3/4. But obviously, in reality, in that situation, there were not four slices of pizza, but it's equivalent to saying you had 3/4 of the slices. So they're the same, but if there were eight pizza slices, there weren't four. That's kind of what's going on here. This simplifies to 7/3/4, and they're equivalent, but that's not exactly the same. This is the reality. This is what actually, these are how many pen packs there were. This simplifies the proportion that there were. It's like with fractions, like here. Okay, I guess that's a sort of analogy, and that might be helpful. But that's how I would approach these sort of ratio questions. And like I said, um, they're in the other paper. The very common theme here. But okay, now we have this. There are two rectangles. QR is 10. I think it's best to label this. 10 BC is PQ. Okay, so we've got a lot of hidden, missing info, a lot of information here, but it's not quite clear to use it. So the perimeter of this shape is 26, uh, and the area of this shape is 45. Okay, so honestly, I think the best thing with this is to just label missing sides. So we know BC is PQ. Well, if BC is PQ, we are. Oh no, that QR. No, QR is 10. Sorry. PQ is also going to be X. Okay, you can say let. So we just label that. But actually, if this is going to be 10, then this is also going to be 10 because it's a rectangle. Likewise, this is also going to be X. And because this is X, this is also going to be X. And we can call this bit Y. And this is going to be Y, so it's a rectangle. And that's all, and that's everything labeled. Cool. Okay. So we are given the perimeter is 26. And we're given this is 45. Well, there's only one missing variable here, one missing letter. So I think it's easier to work with this. So the area PQRS is going to be 45. But we also know we can work out the area of this, right? Well, it's just length times width. So it's 10 times x, which is simply 10x. Which therefore means, well, if x is 45 over 10, which is 4.5. Because if you divide by 10, remember, you're just moving the decimal point by one. But yes, that's 45 centimeters. So now we can fill in x. So x we now know here is 4.5 and 4.5 here. So now we just have y to find. But then we're given this information. The perimeter of this rectangle is 26. So obviously the perimeter, remember, is just adding all the outside edges together. So that means that 4.5 plus 4.5 plus y has to be 26. and then simplify it to get 4.5, 4.5 is 9, and y is 2y, and that's 26, which therefore means that 2y is 26 minus 9 both sides, 17. Um, and that means y has to be 17 over 2, which as a decimal is 8.5. You should recognize. Okay. Now it says to find the length of AB. Well, AB is y, right? This side. So actually it's the same. So it's going to be 8.5 centimeters. So that should be the answer there. So that's to give you these type of questions. I always say I know people really like freak out with algebra, but honestly, I do think algebra is kind of your best friend with problem solving like this. If you don't know a certain thing, just call it a letter, and it would be easy to work with then. Use a bit of algebra, and that's the thing with this question: is label what you don't know like this, and then use the information, and then you can start to work things out, and then it becomes a lot more clearer what you need to do. So yeah, so I've made it. I feel like I made it a lot easier when I started using the letters here for unknown stuff. Okay, and now we're on question 8. Um, so it says for part A, work out an estimate to this one here. So again, there was an estimation question in the other paper. Again, I don't know, I keep echoing this, but I echo this for a reason. The same sort of topics and questions come up every year, especially for paper 1. And here we are. So 63. So with estimation, um, it's best. I don't think there's a real clear cut way of doing it every time the same way. I think you just got to. This is where it gets a bit tricky because you got to try and you got to try and put the numbers sensibly to the situation. So here, it wouldn't be logical, I think, to just call this like 0 by round to the nearest thousand or something. 0 times 0, that's not sensible. So we do need to be a bit uh, clear of what we pick. But actually, this is square root and these look a hell of a lot like square numbers, right? 63.5. I think it's sensible to round this up to 64 and round this down to 100. I think that's a sensible estimation. And so actually then you should know your third laws. So root AB is the same as root A root times root B. So we can split this third up. There we go. Root 64 times root 100. Now actually they're both square numbers. So this is 8 squared, so this is going to go to 8. And 100 is 10 squared, so it's going to be 10. So actually this should estimate to 80. Lovely jubbling. I think that's the best way to approach it. I think you got to realise that they're square numbers. Again, like you got to be conscious of what the example is. If I rounded it down to say 60 and 100, well, root 60 is very awkward to work with, especially without a calculator. So yeah. Oh God, what have I done here? That's how I'd approach it. But again, estimation comes up every year by the looks of it. It's good to notice and practice certain topics that come up. Okay, we are now told this 2.3 to the 6th is 148. So then it says find the value of 0.23 to the 6th, the correct three significant figures. So they're giving you this for a reason. You need to somehow convert this to this. So you need to manipulate this some way. But we know 0.23, well, in terms of 2.3, that's 2.3 times 10 to the minus 1. If you use standard form, right? If you move this power back by 1, you're moving it here, right? So this is in standard form. And why this is good is, well, now we can say 0.23 to the 6 is 2.3 times 10 to the minus 1 to the 6th. And actually, you can distribute it. So now you can say 2.3 to the 6th times 10 to the minus 1. Oh, minus 1 to the 6th. And, well, 2.3 to the 6th is 148. We are given this. And 10 to the minus 1 to the 6th is 10 to the minus 6. That is because you should recognize the third law, index law. So if you're raising a power by another power, you just time the powers together. Okay. So where that's come from. And actually, it says a corrected three significant figures, so we're going to need to write this as an actual number. So this is a third question, not third question. It's a standard form question. So, and actually, we did cover this. Actually, I did anyway yesterday. To go over this sort of thing. But anyway, let's convert this standard form 0.000148 probably. Let's check this. So 148. Well, the decimal point will be here. You want to move it back by 6. So 1, 2, 3, 4, 5. So we're going to need to add an extra 0 here. Squeeze it in. 0, 0. So check it again. 1, 2, 3, 4, 5. Oh. Wait, was that it? 1, 2, 3, 4, 5. Yeah, so that was right the first time. Okay. 3, 4. Yeah, just a double check. Always a good thing to check. And so yeah, so it's two significant figures. Well, significant figure is essentially usually it's the numbers that are significant, which means numbers that are not 0. Well, they're all 0, unfortunately. So, uh, I believe that should be the answer. I believe. I haven't done significant figures in a while. I'm not sure they count the 0 here as a significant figure. I believe so. Yeah, that's right. Yeah, that's it. So significant figure. That's your answer here. That is a lot of work for one. I don't think that's fair. If I'm honest, that is not. Should be at least 2, in my opinion. Um, but yeah, that's how you'd approach this question. So yeah, that's basically standard form without a calculator. They can ask that without a calculator, by the way. So make sure even for non-calc, you prepare for the topics like standard form. They can ask it without a calculator. But that's how I'd approach this question. Um, just think about how they're giving you this. It looks very similar to this. How can I get this as this number here, which I've done here? Okay, then it should mostly follow from that. Okay. Okay, so now we have part C, 5 to the minus 2. Well, again, deal with the minus first. That's going to be 1 over 5 squared. Well, that'll go to 1 squared, which is 1 over 5 squared, which is 25. So that's going to be your answer there. Lovely jubbly. Okay, now we've got a fraction. Again, fraction. Okay, this pretty much exact question came up on the other non-calculated paper. Again, the same topics. I think over half the questions have the same basically sort of topic and working as the other paper. The common questions, right? But anyway, so let's deal with this fraction. So mixing. So again, with when you have a mixed fractions like this, always convert it to improper first. You can, if you are confident, you can do it like you can work with them as mixed, but to be on the safe side, convert it to improper first. So 3 over half. Again, you times the bottom number and then add by the top. 3 times 2 is 6. Add the 1, 7 over 2. And then 1 3/5. 1 times 5 is 5. Add the 3, which is 8. So 8 over 5. So now we're timesing these two fractions together. And that is very simply, you just times the top number and the bottom numbers. Nothing more there. 7 times 8, well, that's going to be 56. And 2 times 5 is 10. We can, well, then convert it into a whole number. So how many 10s go into 56? 5. So it's going to be 5, 10. So then 10 times 5 is 50. To get to 56, you need another 6. But it says to simplify simple form. This can be simplified, right? 6 over 10, well, goes to 3/5. So that is simplified as fully as possible. So that's your answer, right? 5/3 as a mixed number in its simplest form. Cool. Um. Okay. We are given the graph of equation 3y plus 2x is a half and 2y minus 3x is this. Very awkward equations, but they've both been drawn. These lines have been drawn, and it's asking us to solve 3y plus 2x is a half, and 2y minus 3x is minus this, the same fraction. Notice that this is identical to these two, and these two equations have been plotted. What you should know is that the solution to this is graphically, if you plot these two equations on the graph like this, the point of intersection. That is what we're doing every time when you say, when you solve an equation, say substitution. So you'd say like what? Y would be, no, let's say here, Y would be a 6 minus 2/3x if you rearrange it for y. Then you'd substitute it into here. What we're doing when we're substituting the y's or x's or whatever into the equation with simultaneous equations, what we are doing is saying, well, the y coordinate is the same for both lines because the point of intersection, they intersect. At the point of intersection, the y and the x values are the same with both of them. So that means we can substitute y and x into each equation. That is actually why we substitute and stuff like that for solving simultaneous equations, because graphically it's where they intersect, which means the x and the y values are the same. Okay, so that's the key thing to note here. So yeah, where is the point of intersection? Well, it's where they cross, so it's going to be this little point here. So then really you just need to read off the graph. Okay, so uh, it's not clear cut where it is, but it says to estimate. So first of all, let's tailor to the X one. So if you look on the graph, it's about there. So if you, but then you need to work out what each box is. So each box, one box or square. Well, there's 10 squares, so it's going to be 0.1. Okay, so you go 2.1, 2.2. If you can see, I know it's very tiny. I know it is, and then it's between 2.2 and 2.3. So if it, I think 2.5 is a reasonable number here. And then do the same with y. So well, with y, it's actually on this line here. God, not drawn very well. Using a ruler makes this a lot easier. Obviously, I don't have one. So it's this line here. So it's going to be -1, minus 1.1, minus 1.2, minus 1.3. If you read it off there, that should be your answer there. Oh, hang on. No, no, X has to be less than that actually. You don't get a lot of error margin actually. It's between they set 2.2 to 2.3. Interesting. Let's have a look. Let's go. That was mainly because though, I don't have it on paper and I can't draw a ruler. If you were to be more accurate, It looks about as midway. I don't know. So look. Oh no 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 I don't know why I said 2.5. It's because I said 2.5 because it was like halfway between the box. That's why I got carried away. 2.1, 2.2. Then it's between 2.2 2.3. Ah, that's why I was meant to say 2.25. That's between 2.2 and 2.3, not 2.5. That was, yeah, I messed up a little bit there. Okay. Yeah, so that's that. That's how you get that question. Be very careful with the boxes here, what they represent, like I did. I got a bit, so yeah, pick the halfway point between this because I think that's what where it lies, and that's all you have to do, really. So when it's asked giving you a graph or two equations, the point of intersection is the solution. So you just read off the graph, okay, where they cross, as so. Okay. Question 11 now. A bus company recorded the ages of years of the people on coach A and the people on coach B. Here are the ages of 23 people on coach A, and it has to find the information on coach A. Okay, so they're giving us the least and the greatest. Wow, thank you. The easiest bit. So then it asks us for the lower upper quartile and the median. So you should know the median is about the the middle or the 50th percent of the data. The lower quartile is 25th percent, and the upper quartile is 75%. So what is 25% of 23? Um, and actually, there's not a clear cut number to this, unfortunately. Um, uh, let's do the median first. 23 times a half, which is 50%, or 0.5. Well, that's going to be 11.5. So then actually round this up. If you round this up, this actually is the 12th number. So we want the 12th number on this list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 59. And then with the lower quartile, wow, it's 25%, which is 0.25. So actually convert this as decimal to help if you want. 0.25 or a quarter. 23 times a quarter. That's roughly going to be, and you don't have to be exact with this as long as you know roughly where it is. 7, well, not 7, hang on. 6, 12, 18, 24. So it's going to be just under 6, and it's going to be like 5.75, isn't it? 5, 10, 15, 20. 20.75, 21.5, 22.20. Yeah, so it's this exactly, 5.75. We then want to round this up. Okay, so round this up to 6. So this, we want the 6th number in the list. So 1, 2, 3, 4, 5, 6. So it should be 53 here for the lower quartile. Uh, so that rounds up to 12. That rounds up to 6. And similarly for the upper quartile, well, the upper quartile, well, if we know the lower quartile is, well, 25% is 5.75, that means the upper quartile is 3 lots of this. So it's going to be 5.75 times 3. So it's going to be 5, 10, 15, 15.75, 16.5, 17.25. That will round down to 17. So we want the 17th number on here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 64. Oh, hang on. 1, 2, did I count that right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, interesting. Just checked, and apparently they won the 18th number. Uh, Uh, hmm. Normally it makes sense to round it though, so you round that down. Apparently, okay, you round it up then. Okay, so that rounds up to 18. So then you want an 18th number, which is 66. Um, yeah, I guess so because 64 is below 75. We want the first number that is 75 or higher, I guess. So that would be your number there. Okay. But there you go. So that's what you do with that question. Do, 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 do. Then it says here's some information about the ages of people on Coach B. Okay, so it says Richard says the people on Coach A are younger than the people on Coach B. So when it's asking you to compare two data with median and quartile, you should know the median is the average, and also this IQR is the spread or variation of data. So the IQR is bear in mind, is the upper quartile minus the lower quartile. And it's telling you how far away it's spread from the average or the median. So if the IQR is small, that's telling you most of the data is near the median. But if the IQR is large, then it's telling you everything's quite spread apart from each other. So a lot more people are going to be away from the median. So it's going to be a lot more spread. Uh, but in this case, so it's asking us, are younger than people Coach B? So it's on about the average, right? Pretty much. Well, clearly, if you look, the median in Coach B is higher than the median in Coach A. Coach A is actually younger than Coach B here. Look, and every data is the same. So lower quartile, 54, higher than 53. 73 is higher than 66. 42 is higher than 41. 85 higher than 79. So actually, Richard is correct because, and you could just say the median, I guess. Yes, he's correct. As the average median, or the average, I guess, slash median, I guess. Age in Coach B is higher than Coach A, which is obviously 70, which is greater than 59. And also, I guess you want to be really sure, and all data, what do you want to call it? All categories, there we go. I don't know, are higher in Group B, in Coach B, than Coach A. And the only way that can ever happen is because the people in Coach B are older than Coach A. Okay, so then it says Richard says that people vary. There we go. More in age than Coach B. That's on about the IQR. So if we're going to comment on this on the variance or the spread of the two datas, we're going to need to compute the IQR of both of them. So the IQR of Coach A, well, that's going to be upper quartile minus the lower quartile, which is 53. And well, actually, used to spot that should be 13. And the IQR of B, well, that's going to be 73 minus 54. And that is going to be 19. Should be, right? Yeah, 19. Uppercut 73, lower 54, 50. Cool. So actually, the IQR of B, or the interquartile range, is higher than Coach A. Should probably be more specific there. As obviously 19 is bigger than 13, which is the IQR, right, that we calculated. Uh, Therefore, the spread or variance of the ages, because that's what we're working out here, in Coach A is smaller than in Coach B. Therefore, while he's saying Coach A vary more, but it's opposite. Coach A varies less. Therefore, he's wrong. Okay. Okay. Cool. There we are. So that's that sort of question. So yeah, with and often they tend to do this with box plots as well. So remember, with box plots, it's about plotting the quartiles and the median and stuff like that. If you compare the spread of a box plot, which bear in mind looks like this, which again was we asked on the no, not like that, sorry, like that. If they ask you to compare box plots, you talk about the spread. So the spread is the interquartile range. That is this distance here between the upper and lower quartile. The median is the average. So here, obviously, the spread is more because the interquartile range is higher than this one, and the median is higher. So the average is going to be bigger in this one than the other one. So they tend to like to combine, couple this with box plots. And that's essentially what's going on here. Okay, so remember, average is to do with median, and the range or the variance or the spread of the data is the interquartile range. Okay, cool. So now we're on question 12. There are three spheres. The volume of sphere Q is 50% more than volume of sphere P. The volume of sphere R is 50% more Q. So we're given basically a bunch of ratios again. It's basically a ratio question again. Okay, let's just write this down mathematically. So, uh, let PQR represent the volumes of the spheres. Because what we're going to do, you don't have to do this. I think it'd be clear. We can write this with ratio, right? So we know that Q to P is, well, Q is 50% more, so Q is going to be 2 to 1. So the volume of sphere, oh, hang on, no, 50% more, so it's 1.5, right? It's 50% more, which you can scale to 3 to 2. Okay, so the volume, so sphere Q is 50% more than P, so Q would be 1.5 lots of P, and we can write that as this ratio here. Likewise, sphere of R is 50% more of Q, so that's 1.5 Q. We can say the same sort of thing here. So R to Q is going to be also 1.5 to 1, which is going to be 3 to 2 again. So then it's saying write P as a fraction of R, the volumes. Well, actually, like when you have two ratios with three objects like this, you can combine them together. So find the common link in each ratio. So we have Q to P. So Q is going to be right. Q's in both. So let's write this more clearly then. So we make sure Q's on the same side. So Q to R then is going to be. Now let's rewrite this again. Sorry. So Q to P is 3 2. And we know that Q to R, so we're going to flip the order. It's going to be 2 to 3. Well, actually, we need to make the numbers the same here, because if you can then equate them as Q to P to R in the same ratio, if the number on the Q is the same. So how can we get this? Well, we can times by 1.5, right? Because if we times by 1.5, that will get us some two times 1.5 is 3, which matches this. Okay, so we get 3, and then that should be 4.5, I believe. Uh, you can check this if you're everyone's sure, because 1.5 is 3 over 2. That would be 9 over 2. Which you should be able to work out is 4.5. So if everyone's sure with the decimals, there we are. So now we can say we can combine them together, right? So Q is 3 on both of them. So now we can literally combine them. So Q is 3, then P is know is 2, and then R we know is 4.5. And we want whole numbers, right? So we can scale this by 2 to get rid of this. So that's the same as saying 6 to 4 to 9. Cool, but then it's saying express P as a fraction of R. So we know that from this 4P is 9R. Therefore, P in terms of R is going to be 9 over 4R. So as a fraction of the volume of R, P is going to be 9 over 4R. There you are. Okay. Hang on. Uh, no, hang on. It's the other way around, isn't it? No, that's not how you interpret it. Apologies. The other way around. Ignore me. I'm chatting waffle. We can then say P to R, right, is 4 to 9. That's the ratio. Cool. So it's saying for every 4 lots of P, you get 9 lots of R. So, which is equivalent to saying 129 over 4, because we want P. So to get P, you can just use this. Yes. Okay. Okay. Right. Uh, Well, yeah, just like I'm getting a bit stuck here. I don't even know why. I haven't done these in so long. Uh, so long. But okay, so say for 4 lots of volume of P, you get 9 lots of volume of R. Okay. So from that, if you read it like that, P, if you want to reach R, that's going to be 4 over 9. Because if R is then 9 parts, P is 4 over 9 times by 9, you get 4 parts back. Okay, so actually it's the other way around. That's how you interpret it. Okay, so if it's asking you like this, just think about how the parts are the same. So then, if you want to get so again, if you have R, if you want to put express P and R the same, you need to make sure it cancels like this. I don't know. I don't think I explained that right. How do I want to explain this? Du- 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 du. Well, yeah. So P has to be 4 parts, right? And R has to be 9 parts. So if you want P in terms of R, well, you're going to need 4 parts has to be equal to some number times 9 parts. Well, to get X, well, X is just going to be 4 over 9. So that's how you can switch between the two. Okay. So then you express 4, which is P, in terms of R, which is 9. So then 4 equals 4 if you let X is 4 over 9 here. So that's where that comes. That's how you read a ratio. Yeah, I should probably brush up on that, shouldn't I? But that's a good thing, right? Like this is showing where the common pitfalls are, right? I imagine a lot of students would trip up on that, say 9 over 4, like I did. Um, but yeah, that's what ratio means, essentially. That's how you'd convert from a ratio like this to this. Uh, I'm trying to think. There's a better. I think I know there's a better. We'll come. I'll come back to that. I promise. Okay, I will come back to that once I think of it. But anyway, let's ignore that. There is a better way I can explain that. Question 13. Sorry, a little break there. Given that n is going to be any integer, prove that. So again, it's another algebraic proofs question, which again was asked in the other paper. So again, similar topics once again. So I said for integer n greater than 1, well, that's going to mean n is 2, 3, 4, so on. We want to prove that this is another odd number. Okay, so it's a bit different to perhaps other algebraic proofs. It maybe not be directly clear that you what to do. Um, but I can spot it, but I don't know how to explain it. Okay, you want to prove it's never an odd number? Well, let's see what we can do with this. There's not a lot we can do apart from factorize, right? Let's see what happens. N squared minus n is n of n minus 1. Okay. Now, actually, we are given that n is an integer, and so that means that n and n minus 1 are consecutive, which means the next to each other. So, hang on, not this, go away. God's sake. They're consecutive, which basically just means the numbers are next to each other. So, 2 and 3 are consecutive, 4 and 5, 3 and 4 are consecutive, 5 and 6, 6 and 7, 7 and 8, so on. So that's all that means. Now, actually, what that means is actually if you have an odd number, the next number has to be an even, and vice versa. If one of them is even, the next one has to be odd. So that means one of these numbers must be even. Therefore, the product and minus 1 is even because even times odd gives an even number. And you can spot this because say if we did 2k times another number, an odd number 2m. Well, you could that'll be 2k of 2n minus 1. Well, we could just bring the 2k in. You can bring the k in, and then it's factor of 2. So it has to be even. But you don't have to do that. But you should be able to just recognise that even times odd is even. Um, and yeah, that's basically the proof. And this won't be 0 either because n's greater than 1. So n has to be 2, 3, 2, 3, 4, and so on. So n minus 1 has to be at least 1. So you don't have to worry about zeros or negatives. Okay. So yeah, that's the approach for that. If you ever stuck, especially something like, just think about what you can do with it. Okay. And that's a really, especially with proof like this, factorizing is a good way to go. Because then it allows you to think of the factors, and it makes you think using this what can be even and what can be odd. Okay. Because that's what these questions boil down to is considering even and odd numbers. So that's where that's a massive help. Okay, so question 14. Exact values. I did talk about this yesterday. I did a little tutorial video on it. So remembering exact values. So I like to draw a hand, a really a bad hand. Oh God. And what you can do is label each of the all the trig values you need to know. So it's starting from 0. Oh, I deleted it now. 1, 2, 3, 5. The hand's terrible. Uh, Basically, just draw something with 5 fingers or 5 parts, essentially. So that's going to be 0, that's going to be 30, 45, 60, and 90. Those are the numbers you do need to know with trig. So the rule is with tan, you want to divide the sine of it over the cos of it. Now, with sine and cos, you want to it boils down to the root of the finger number over 2, always over 2. And I did this last stream. I did go over it. So if you're a bit unsure what I'm on about, do watch my last stream. It should be if on YouTube anyway. It will be in my playlist in the GCSE Maths section in the non-calculator part. Anyway, so let's just show what I mean by this. So root finger. So the finger. How many fingers do you go from 0 to 90 or vice versa? So sine. So sine, you go start from the 0 bit. Okay. So to get from 0 to 60, you have to go 1, 2, 3 fingers. And that is over 2 divided by, and then you find cos 60. Now, cos is the other way around, so you start at 90. So you move 1 finger. So it's going to be root 1 over 2. Now, actually, the 2's cancel, so you're left with root 3 over root 1. Root 1's just 1, so then divided by 1 is just root 3. Likewise, then sine 60. Wow, sine 60. Well, you just worked it out, actually. It's going to be root 3 over 2. You can spot this again, because go from 0 to 60, 1, 2, 3, root 3 over 2. So therefore, tan 30 times sine 60, that is going to be root 3 times root 3 over 2. Cool. Well, actually, root 3 times root 3 is just 3. So that is your answer there, 3 over 2. Yeah. See, not really. The out is not bad at all. Once you know the values, I think it is a good idea to just try and learn the back. This trick, I think, is quite. It should be fairly easy to remember. Some people obviously remember it with triangles. Personally, like I've always remembered this even since when I did GCSEs. And I still remember it now. Still know the values like this off the bat because of this trick here. But you can remember triangles as well. There's got certain ones. I don't like to remember the values you need to use because they're quite specific. I think like 1 and root 2. I don't know. But this one I think is fairly like straightforward once you get to grips with it. I don't know. But that's one technique. Obviously, if you have your own technique and it works well, that's great. But yeah, There we are. Okay, so we're on question 15 now. The diagram shows a solid shape. Fairly common one this is, a hemisphere, like a cone, like an ice cream cone anyway, with like an ice cream on top. So the shape is this cone here with a hemisphere. So a hemisphere is just basically you cut off half a sphere. That's all it is. As shown here. So they stuck it together. The height of the cone is 10, this H here. The base of the cone is diameter 6. The hemisphere is a diameter 6 here. The total volume is k pi. Work at the volume. Okay. Okay, this is actually fairly nice because we give you all the formulas you need here. So it's just simply working out what the missing dimension, the values, right? So the volume is going to be the volume of the cone plus the volume of the hemisphere. So let's work out the volume of the hemisphere first. That's the cone, sorry, first. Well, it's giving you here. It's a third pi r squared h. So radius of cone. Well, look, what's it told us? The cone. The base of the cone is diameter 6. So if the diameter is 6, the radius is half of that, so it's going to be 3 centimeters. And the height of cone, oh god, that is very simply just 10. It's giving us the number here, 10. Uh, so therefore the volume is a third oh, times pi times r squared, that's 3 squared, which is 9, times 10. Now actually that you should spot 9 cancels with the 3 here, so you left with 3 times pi times 10, which is 30 pi. And you should leave it as pi because see here, it's in the form k pi. Okay, so now we're going to work out the volume of the hemisphere. Now the volume of the hemisphere, so I said it's half the volume of the sphere. So it's going to be a half of 4 over 3 pi r cubed. Now actually, the half times 4 over 3 is 4 over 6. Well, the 2 cancelled with the 4 here. So you're just left with 2 over 3. That doesn't look like a 3, does it? And that looks like an X for some reason. It's a heart, it's 2. There we go. So hemisphere is half of a sphere. And you can kind of see that a bit up here. See how we cut off half a sphere? And that's where that comes from. So yeah, so now we just need to work out the radius. So radius of hemisphere. Well, that's simply, well, it tells us the hemisphere has diameter of 6. So again, it's the same. So the radius is going to be 6 over 2 because diameter is double the radius. So then the radius is half the diameter. But that's going to be 3 centimeters. So therefore, the volume well, that's going to be 2/3 times pi times 3 cubed. Now, 3 cubed is 3 times 3 times 3, which is 27. Now, actually, the 27 again cancels with the 3, so you're left with 2 times pi times 9. Oh. Uh, 27 over 3, 27 divided by 3 is 9. So you're left with 18 pi. So therefore, the overall volume, or the total volume, it's just going to be adding the cone and the hemisphere volume together. So the cone volume is 30 pi, and the hemisphere volume is 18 pi. And that is 48 pi. Oh, 48 pi. I'm getting ahead of myself here. And actually, it's in the form k pi centimeters cubed. And K here, as you can read off, is 48. And that's a very, I think that's a very nice question. They give you everything there. It's just to work out. You don't really need to work out anything complicated either. In my opinion, I don't know. They give you a lot of if it. They just got to work some stuff out quite simply. Okay, one question 16 now. Okay, combinations. Um, and also to note, this is what I mean. They can convert pretty much any topic into non-calculator, which is why you got to revise everything. Because even if like a volume question like this with pi and all this, they can make it non-calculator. Oh dear, non-calculator if you just leave it in terms of pi. Um, so yeah, so question 16 now. I think we're headed towards the end of the paper, sadly or fortunately for most of you. Okay, so there are three dials on the combination lock, obviously shown here. Each dial can be set to 1, 2, 3, 4, 5. The three-digit number 553 is one way. Work out the number of different three-digit numbers that can be set for the combination lock. Okay, you can almost create a different list. So from the first digit, you could pick from five numbers 1, 2, 3, 4, 5. Likewise, second digit 1, 2, 3, 4, 5. And the third digit 1, 2, 3, 4, 5. And with this, it's like the product rule of counting. You essentially with each list, if you're choosing everything from each list, you times by how many there are in each list. So there are five from list one, and then you choose them from list two, that's another five, and then you choose from list three, which is another five. So really, it's just 5 cubed, but you should recognise 125. And I guess the way to see this is if you pick number one first, you can pick from any of these five. Uh, what? Anyway, you can pick five. Any of these five. So that's five options. There we are. Then with the second one, again, you pick five options next, and three options. Five. So each number has then five options for the second one. So that is immediately going to be 5 times 5. And then with the second one, likewise, there's another five options you pick afterwards. So from here, you can pick another five. And that's the idea of this. So you times then each time. With these combination questions, it's called combinatorics. Formally, it's the study of choices and combinations. Um, just create a list of all the options because usually it's like this. Normally they ask something like, "Oh, there's a starter menu with 6 items, there's a main menu with 10, then there's a dessert menu with like 4 items. How many options can you pick?" Something like that. So there's three distinct lists, or four, or how many lists of options, and you got to work out how many are in each list and times them together. Okay, okay. So then it says in part B, how many possible three-digit numbers have three different digits? Okay, so we have to think a bit more deeper about this one. Okay, uh, and I guess with this type of question, if you're a bit unsure, try and sketch some possible combinations. So one, uh, okay, well one, you cannot have one there. So there's going to be let's say you pick one first. Then you're gonna have pick this one. Then there's only four options you can have, right? So it's gonna be four options, and then obviously you can't have one again, but you also can't have one of these again. So say if we had one and then two, we can't have two or one. So it's gonna narrow down to just three choices. So then if we pick two then first, likewise it's going to be you can't have two again, so you can only have four numbers here. And then again, you can't have the other number, so it's going to be three numbers left to choose from. So essentially, what the idea is, you start with five numbers to choose from, uh, but then you can't pick that number again. So it's going to have to be four left you can choose from the second list, and then from the third list where you've already picked two digits, so you can only have three numbers left to choose from. So you basically got to, again, think about the list and think about how many you have to cross off. So you obviously pick all five of them from the first list, but then to make sure you have different digits, you can't have the same digit again, so you have to cross one out. And then with the third one, you've already picked two different digits, so you have to cross two out, so you're left with three. So that's where this comes from. 5 times 4 times 3, work that out. Well, 5 times 4 is 20, times 3 is 60. So that is how many different digits um, you can have, and that's that. So again, with this, you can, if you are struggling a little bit, start to write some possible answers out, and then you should start to pick a pattern up, like I've done here. But yeah, that's the tip with that. But yeah, oh, another ratio question, lovely. Okay, so we are given that x squared, 3x plus 5. Ah, this might explain the other ratio question actually now. Okay, so with this, if two ratios are equal, you can actually equate them if they're identical. So that means if one of them is 1 as well here, so if I have 1 to a number, that number has to be 2. So for example, if I have 1 to n is 1 to 2, n has to be 2. So with they love asking these algebra ratio questions as well. I've noticed. I predict this will come up on one of the three papers. Predict with like 98% certainty, and it follows the same way each time, and it comes from like what a ratio means, I guess. So we want to essentially, that's the strategy to make this match with a number of this. So the easiest way is to get it to 1 to 2. So let's divide this by x squared, this ratio here. So that means 1, 3x plus 5 has to, over x squared has to be one the same ratio. And it's identical now because look, they match. Like I said before, 1 to n, 1 to 2. N has to be 2 for it to be matching, be equal, right? It has to be. So we scaled it down to the exact same ratio. That's all we've done here. So that's the strategy. And once you've done this, it's a it's a doddle. It really is. Once you realise this first step, it should make sense afterwards. So hopefully you see what we've done here. So we need to make it comparable. So we need to make all the numbers the same. So divide it by x squared to get 1. Okay. So now what we can say here then is 3x plus 5 over x squared has to be 2 from this. Okay. Has to be. And therefore you can times by x squared. It's just solving a algebraic fraction. Again, on the last paper, they asked us to solve an algebraic fraction. Again, I know it's probably annoying by now. You hear me, banging on about, they asked about this question, this topic in the other paper. That's why, because you learn those topics, it will most likely come up in your one. Yes. So yeah, solving this fraction is going to be 2 times x squared, 2x squared. So therefore 2x squared minus 3x minus 5 equals 0. And so essentially, what we've got to do here is to solve this quadratic, which should be easy to do. There are, I wouldn't advise, with a non-calculator, I do not use quadratic formula. There are two ways you can do this, completing the square or factorise it. Let's see if we can factorise first. So I want to consider, there are many methods you can attempt to factorise. whichever one works for you. But this is the one I think most people do, which is to consider the a times c. So the 2 times -5, which is -10, and then think about um, what times to give -10 and adds to give -3. Well, what are the factors of -10? Uh, well, 10 and 1. They won't add to give 3. No way. 5 and 2. Yeah, 5 and 2, right? So I think -5 and 2, because -5 times 2 is -10. -5 add 2 is -3. So that's your answer here. So what we are saying here is, what this allows us to do is express minus 3x, break it into -5x plus 2x, right? That's what this is doing here, and that's what we're achieving. So yeah, let's bring this in. So let's say -5x plus 2x minus 5. Now, with this method, both parts here and here should factorize, but actually they don't. Actually, no, they do. Yes, they do actually. So you can factorize an x here, 2x minus 5, plus 2x minus 5. Let's get rid of this for now. Equals 0. Right, 2x minus 5, it's the same way as saying 6y plus 5y equals 0. Y is common in both of them. Here, y is 2x minus 5. It's the same as just saying that, okay? We factorize. That's what's happening here. We're just collecting like terms, essentially. Now, we can factorize again. So 2x minus 5 is the same on both of them. And then we have x here plus a 1 equals 0. And you can check this work. If you expand the brackets, you should get this quadratic back. 2x squared plus 2x minus 5. That's minus 3x, which is here, the original one. Minus 5. Yeah, so that's right. So now we're solving. So literally set each bracket equal to 0. So 2x minus 5 equals 0. So x is 5 over 2. Or x plus 1 equals 0. So then x is minus 1. And there's your two solutions. Okay, so the possible values is, what was it, 5 over 2 and then minus 1. Should say or x equals minus 1. And that's how you solve it. Once you spot that initial step of making the fractions the same, like this, the ratios the same, sorry, it then follows through quite nicely, right? You should be able to then solve an algebraic fraction, solve a quadratic like this. That should be routine by now, right? So that initial step, but that's all. That's how you approach a question like that. Okay, well, question 18. Express root 3 plus root 12 in the form a root 3. Okay, so when you're adding two surds, the only way you can add them is to make sure that somehow uh, you can write it in the same number, the same surd, right? But root 12 is not root 3. So we need to somehow get it in terms of root 3. Well, root 12, you should recognize the third law again. Root AB is root A times root B. So actually, root 12 is the same as root 4 times 3. And then you can bring it out together. Root 4, root 3. Now, root 4 is actually 2, right? 2 squared is 4. And that's 2 root 3. And actually now it's in terms of root 3. So therefore, root 3 plus 2 root 3 is 3 root 3. Lovely jubbly. And therefore, yeah, 3 root 3. So I guess a is 3 if we wanted to, 3 here. If we compare a root 3, 3 root 3. Okay, so I did explain this last time, but in the others for the other paper, but I'll go over it again. So with surds, again, I think a lot of people overcomplicate it, make it harder than it is. All that surd is a number or a root that looks like this, root n, where n is not a square number. So n is not 1, 4, 9, 16, which numbers square root to give a whole number. So root 1 is 1, root 4 is 2, root 3, sorry, root 9 is 3, and so on. Okay, so if a number is not that, so say if we have root 2, that is a third because that doesn't give a whole number. Root 3 is a third because that's not a square number. It won't simplify the whole number. But root 4 is not a third because it just goes to 2. But then root 5 is a third because there's no whole number of that. If you put it in the calculator, this will give it a decimal that goes on forever. It will not give a whole number because 5, 3, and 2 are not square numbers here. And that's all it is. That's all it is. And so the idea of this, when you so that's a third, and then with third questions, all you're doing is this. You are just looking for a factor or factors of 12, factors in there, and then simplify it with this. So 4 and 3 going to 12, and so you can split it up. And actually, eventually, you'll get some square numbers that'll simplify. That is the whole idea. Third is nothing more. Third is literally where it's not a square number. That's all it is. That's all you need to know. Okay, so root 2 and root 3 are thirds, for example. Root 4 is not a third because root 4 is simply 2. Okay, but then root 5 would then also be a third because it's not a square number. Hopefully that makes sense. That's all it is. Okay, and with adding thirds, it's like collecting like terms. So if this is saying y plus 2y is 3y. If y is root 3. Nothing more. That's all it is. It's like collecting like terms. The same thing. That's all it is. Okay, if you just remember that and this little rule here, that's all thirds are. That's all they are. Okay. Hopefully then that clears it up. Nothing more needs to be said on that really. But yeah, so then part B, express this in the form root B over C. Okay, well, I spot immediately this is a fraction with a irrational denominator. It's a third on the denominator. And I noticed the third is on top, so it's been rationalised. So I think the best thing to do is to rationalise the denominator, right? So root 3 over root 3 is root 3 over 3. So you brought this denominator, the third, to the top, the numerator, like this. And that's all what rationalising the denominator means. A third is irrational, so to make it rational, you get rid of the third, as so. Get rid of it on the denominator. All that means. Okay. But now it's one over root 3 to the 7. So now, uh, actually, root 3 over 3 to the 7. Uh, no, because what we can then say is we can convert this. So these are both in powers of 3. So this is 3 to the half over 3 to the 1, right? Now, actually, you should recognise the third law, index law, sorry, a to the m over a to the n. So a number with different powers. You simply subtract the powers. So this is 3 to the half minus 1. So it's going to be minus to the half. And actually, it's the same as what's going on here, right? That's the same as this. But actually, what we can then say is 3 to the minus a half of to the 7. And you should also recognise this index law, which we did actually quote in another question, didn't we? A to the n to the m, a to the mn. So if you have a power raised to another power, you just times the powers together. So minus a half times 7 is 3 to the minus 7 over 2. So now we just need to get this into a number again. Well, 3 to the, again, deal with the negative first. 1 over, which a negative like 3 to the minus 1. It's just it's just a reciprocal. Okay, you should recognise that. So, that's going to be 1 over 3 to 7 over 2. And so, then we deal with the half. So we're going to square both, square root both sides. It's going to be root 1 over root 3. Because that's the same as saying 1 to a half over 3 to a half raised to the power 7. That's what this is doing here. Okay. So then you deal with the denominator part, the fraction. So half times 7. Anyway, you get this. Now that simplifies to 1 over root 3 to the power 7. Oh, we just got back to where we started. uh, but yeah, so then just times by 7. So then this is simply the same as saying 1 to the 7 over root 3 to the 7. Now root 3 to the 1 to the 7 is 1. Now, root 7, you can spot as saying root 3 times root 3 7 times. So root 3 times 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 root 3. I thought it would have got somewhere else there, but I guess not. But yeah, that's all. That's root 3 to the 7 times it 7 times. Now, actually, you should spot that root 3 times root 3 is just 3. So this is going to be 3. That bit's going to be 3. That bit's going to be 3. And then you just got another root 3. So the product is simply 3 times 3 times 3 times root 3. 3 times 3 times 3 is 27. Root 3. And that's, so therefore this goes to 1 over 27 root 3. And then you can rationalise it times by root 3 over root 3. That's going to be root 3 over 27 times 3, which is root 3 over 81, right? And that is your final answer because it's in the form of this. So root b over c. So b is 3 and c is 81. So it looks like this now. Okay, turns out I didn't have to do all of this. That's so funny. I just ended up with what the question said. At least my working's right. At least, clearly that must be. But yeah, you could spot that right away though. You could do this product right away. You should know 1 over root 3 to 7. You should be able to spot it 1 to the 7, which is 1 root 3 over 7. You can do this. Okay. But yeah, it's a bit messy. I do apologise, but basically, you only want to focus on this part of the working. In fact, actually, I'll get rid of all this actually now. This bit is all waffle then. So you want to see more clearly what's going on. That's what's going on. Uh, yeah, so we start here, right? So this bracket here, it's the same as this. That's what's going on here. So that's all the working you need. But yeah, oh god, I do apologise if that's messy though. Okay, one question 19. Again, just again to echo, there was a third question on the last paper, so there's probably going to be thirds on your paper as well. If it keeps coming up on paper 1 and so forth, it's going to be on your paper 1, most likely. Okay, so load your thirds. Okay, so now on question 19. Given that this expression is equal to this, find the value of a and b. Okay, you should actually spot that this is completing the square Say if we didn't, but then you can just expand both sides. So this is going to be x squared. I don't like this is just if you're stuck to see what to do. Just expand and see what happens. X squared. Well, x minus a, x minus a. That's going to be x squared minus ax minus ax. That's 2ax plus a squared minus b. But I don't recommend this because you get a very, very nasty um, a simultaneous equation. Because what you get from this is saying -6, the x coefficient, is got to be minus. Actually, no, it might be fine. Minus 2a. So therefore, a has to be 3. And the constant 1 plus 1 has to be a squared plus b. A squared minus b. This is the constant here. Well, actually, a squared is 9, 3 squared. So therefore, b is 1 minus 9, which is minus 8. Well, that comes from 1 is 9 minus b. So then if you add uh, b is 9 minus 1. Hang on, that's not right then. So b is 9 minus 1, which is 8. Now, the way you, that's if you're stuck on what to do. What you should realise is that it's completing the square. This is complete the square form. You should recognise this. And part B shows that you must know this. But, so how you complete the square? Oh dear. Well, focus on the x bit first, because obviously this is all the x bit. This is just a constant, so focus on the x. So what you need to do is x halve this, just halve it, squared. Then you minus 9. So you square this and take the negative. So you don't do minus 3 squared. You don't do that because that'll just give you 9. What you instead want to do is you want to do minus 3 squared. Notice the difference. So you square 3 first and then tag a minus on. So that's what you want to do. Always remember it's minus. And then you add 1. Obviously, because we've got a 1 on the end of it. And you get this a lot more quicker. X minus 3 squared minus 8. So that means a has to be 3. If you compare x minus 8, x minus 3, minus 8. So then minus b. So b's 8. So you get that very quickly. So those are two methods, but this is what you really should be doing. Okay, this completing the square bit here. This is if you're just very stuck, if you forgot completing the square, which you hopefully you shouldn't. You can do it a bit more algebraically, head on. But sometimes it might not be nice, so just be careful. But you should remember completing the square. And then it says for part 2, write down the coordinates of the turning point of this graph here. The turning point of this, so if we have a complete square form, the turning point is going to be AB, x minus a, so then it's going to be a and b. So in this case, a and b is simply 3 and 8. I'm going to explain why this is though. You probably just memorized that, which I don't blame anyone. You probably just memorized to do that to take the negative of the bracket, x equals a, and then take y to be minus b. But let's explain why this is. Um, so we have x minus 3 squared minus 8. That's what we did in part A. Now, this is a graph, right? Equals y. This whole bit is a graph. It's the same graph as the quadratic. Okay. So the minimum, so our graph, because the x coefficient is positive, it's x squared, it's going to have this smiley shape. Smiley because it's positive, right? A frowny shape would be a negative x squared. But here it's positive, right? This is the turning point, the point where it turns essentially. It changes direction almost. It dips down and dips back up. But actually, the turning point is also the minimum point. It's the minimum y value. So if you plot this on a graph, This is the lowest y coordinate of the graph, which is useful for many things. But anyway, so just not to bore you, this is the turning point. Now, this is also the minimum point, as I said. So what we need to do is to find the minimum value of this expression here. So let's look at this carefully. So to get the minimize this to get the minimum value, well, this bit varies. This x minus 3 squared. This is just a constant. This doesn't change at all. No matter what x value we plug in, this would just be minus 8. But this bit will vary with values of x. Now also notice this is squared. So that means x minus 3 squared is always going to be at least 0. It's going to be positive, right? Always. So to minimize this, to get the lowest possible outcome, the lowest value, it has to be 0, right? It has to be 0 because that's the smallest it can be. Now, x minus 3 squared equals 0. That's the same as setting the bracket to be 0, which means the x coordinate, the turning point, is the negative of 3. It's the opposite almost. So that's why you solve the quadratic, the bracket, set it to 0 to get the x coordinate, okay? Because the lowest it can be is 0. Because it's squared, it's a square number, okay? So that's how you get the minimum x value. So then, because this is constant, because this has to be then 0, you're then going to have 0 minus 8. And actually, it's just going to be minus 8. And it's always going to be this number outside. That's then the y, because this is y. This is now, say, y. Has to be minus 8. That's the minimum y coordinate. Also, it should be minus 8, shouldn't it? Yeah. So, yeah, so whatever number's outside the bracket here, that's your y coordinate because this has to be 0. If you want to minimize it, it's 0, or else it'd be over 0. So that's the minimum, the lowest value it can be, the square. No matter what x value you plug in, it has to be at least 0. So then that goes to 0, so you're just left with minus 8. So then the y, which is all of this, has to be minus 8. Hopefully that bit makes sense, but you don't have to know that. If you just know to set the bracket to 0 and then this number's the y, that's perfectly fine. But for 1 mark, usually they like asking to complete the square, which then allows you to see the turning point of the graph. Okay. Okay, so yeah, so generally it's only 1 mark, so you just need to read off the completing square. So you need to recognise this is in completed square form. So then, just to reiterate, if it's of this form, the turning point is going to be setting this to 0, so x has to be a, and then y is just the number outside, so it's minus b, not b, but minus b. Okay. Uh, Let me just write that again, just to be clear. And yeah, so that's all that is that question. Okay, now we have we had again the kind of exact same question as last time. Inverse and direct proportion. Again, the same sort of question. Um, okay, so like and because of that, I'm going to reiterate what I said last time. But hopefully, this is again the point. As you do more past papers, you start to pick up the same questions and the same method and stuff, so you can tackle the questions more. And you become more confident. But yeah, so I'm going to reiterate what I said before in the last stream when I came with this sort of question. Inverse proportion, again, people love to confuse proportionality and make it harder than it is, in my opinion. Inverse proportion just literally means uh, H has to be in the K over P. It has to be this. Inverse proportion, you might see this little thing here. It means proportional to. Ignore that. That means nothing. All you need to know is proportion, say y is inversely proportional to x. It's of the form k over x. Like here, h inversely proportional to p, h is k over p. K is just a constant, also known as a constant of proportionality, but it's just a constant. And likewise, direct proportion is p is directly proportional to the root. So it's uh, k over root 2, but obviously the constants are different. So it's going to be uh, pick any number. Uh, I'm struggling to pick a number. M over root 2, say, okay? That should have a constant M. K and M are constants. I should probably say that. Obviously, write that in the box, right? In fact, no. Just to be clear, what to write down. K and M are constants. And again, like inverse proportion. If y is inversely proportional to x, y is k over x. If y is directly proportional to x, it's just kx. And the reason behind this is because we want to show the relationship between the two variables, the h and p, y, or whatever. If they're direct proportion, that means one directly varies with the other. Uh, they vary in the same way. So if x increases here, y also increases at the same rate. So this is direct proportion. And notice it looks like the graph struck y over x. And it is. If k is 1, it's a straight line. And that's the idea of this. As you increase x, y increases too. Likewise with p. If p increases, root t is going to increase. Inverse proportion, however, is the other way around. So as one variable uh, increases, say x, the y will decrease. So as further along you go on the x-axis, y goes down. Okay. So this is the graph 1 over x. But then as y increases, go up y, x decreases. So the x values go smaller. You go, yeah. So then direct proportion, both increase in the same direction, the same way. One increases, the other increases. And also one decreases, the other one also decreases. But with inverse, again, inverse, like the opposites almost. If one variable increases, the other decreases, and vice versa. And this looks like the reciprocal graph, and it is because it's 1 over x. K over x is 1 over x times a constant. A constant just makes it, it's essentially still the same graph. If you think about your graph transformations, same as y over x. This is a straight line, this is a reciprocal graph. And that's the idea with inverse and direct proportion. It's about describing how two variables link and change with each other. If one increases, the other increases or decreases, and that's all it is. At the end of the day, and at and on the and fundamentally, these are just what you need to know. Just convert it into these equations. If it's direct, it's kx or p's m root t, k root t. If it's inverse, then you use k over the variable. Hopefully that made sense. So you see this stuff about the symbol, like H is this weird symbol, uh, P, K over P, 1 over P. It makes it more that's all it means. It's this formula here, it's this equation here. Okay, we've got that over with. Just know these are constants as well. That's all it means. And now it's just essentially finding the values of K and then the missing values. So H is K over P. We're also told that H is 10 and P 6. So substituting this in, we get 10 is K over 6. Which then means you times by 6, you get 60 is K. Which means H is 60 over P because we found the missing value. So now we've got a direct link between H and P. We also know that P is m root t, and we know that when t is 144, again at P6, so 6 Oh, hang on, what am I doing here? Oh, God. Ugh. Ah. Ah, stupid thing. Oh, God. I'm still new to this, man. Oh, God. Anyway, so 6 then is going to be m root 144 if you directly substitute the values in the numbers, right? Now, root 44 is simply 12. 12 squared 144. So 6 is 12m. 12 times m. So that means m is 6 over 12, which is a half. Okay. That means then that p is a half root t, or 0.5 times t, however you want to word it, but I like fractions. Then it says find h in terms of, oh, I can't really see it here, in terms of t. H in terms of t. Well, we have these formulas here. P's half root t, and we know that h is 60 over p. Well, we can substitute p into here, can't we? So then we get h is 60 over a half root t. And so we can simplify this, can't we? So 60, you shouldn't, 60 over a half is 120. 60 over a half. You can think of this as saying 60 divided by a half. And then if you use KFC, that's same as 60 times 2 over 1, which is simply 120 over 1, which is 120. So that's why that simplifies to 120, if you're a bit unsure of that. Or obviously you could say 60 divided by 0.5, and you should recognise that same as doubling 60, so 120, over root t, and that should be our answer, because it has to write h in terms of t. And yeah, so h is equal to 120 over root t. You could rationalise it, but it doesn't really ask to do that, so you don't have to. You could say 120 over root t times root t over root t, which is 120 root t over t. But we don't need to. We just need to find a way to express h in terms of t. It doesn't ask for a specific form. So you can write it in this one, in this form here, rationalise. It's completely up to you. Okay. Uh, cool. And the mark scheme accepts that form as well, by the way. Okay, functions. Okay, functions make sense if you just follow the notation. You'll see what I mean. So f and g, such that f of x is this and g of x is this. Find inverse of f. Okay, so what that means essentially is if we say y is f of x or 3x minus 1, the x and the y flip. So essentially now we're saying x in terms of y. And the reason for that is because when we have a graph f of x, say f of x looks like that. Obviously, it's obviously not this one, 3x minus 1. Actually, yeah, no, let's draw it 3x. Let's keep it consistent with this one. So 3x minus 1. Well, y is x, 3x. Look like this. And then minus 1. Shift it down a little bit. So it would look something like this, right? 3x minus 1. Okay. Oh God. So, actually, no. It's messy. It's messy. I'm just going to draw a general function. I'm not going to be specific to this. Uh, Purely because I can't just draw straight lines, so I think it's going to confuse people. Say if you have a function that looks like this, say, where that is f of x, or y is f of x. Now, if we reflect it, no, sorry, if we find the inverse, Actually, that's the same as reflecting in the line. Y is, I believe, minus X. So, do. No, it's Y is X. Sorry, it goes to minus X, but that's not the line you're reflecting. Uh, uh, I did need to double check that actually. You don't need to know this for GCSE though. But you will need to know for A level. If you ever do it. Anyway, so the idea is, if you draw Y as X, you reflect it in this line. So that's your inverse, right? So, uh, it looks something like this. So this would be inverse, and the idea is the X and the Y's change. So if you reflect it in this, the Y coordinate will go to the X one, and the X one will go to the Y one. Uh, so if you reflect XY uh, into Y's X, it becomes YX. So see the Y and the X change places. That is all that inverse functions are doing. They are, and that's the idea. So the inverse is saying it, um, uh, of X. So what value of Y, what value of X gives this value of Y. Yeah. So if you have S minus 1 of 6, what value of X here gives F of X equals 6? That's the whole idea. And that's the geometry. What's going on here? You don't need to. If that confused you, I do apologize. You don't have to know any of that. But that is why you're taught essentially, and what you need to know is you flip in the y and the x positions. But the reason why you're flipping the x and y positions is because you're reflecting it in the line y is x, the curve, the line here. So then, because if you're reflecting it here, so I have a point here, the point is to then go there because the x and the y are changing places. So it's on the x-axis, now it's on the y-axis. It's changing places. The x and y change with each other. If you reflect it in the line y is x, okay. Okay, so that's the explanation behind that. So now we just do the method. Let's do the method now. If you're confused with that, I do apologise. But that's the explanation for those who are really interested or really like for the people who need to understand why and the reasoning behind why they do it. That's for those people. But for everyone who just wants another method, so you want to switch y with x. So with function question, we want to find inverse. It's a very good idea to set y to be f of x, um, or the function, right? So now we rearrange the equation for x in terms of y. So y plus 1 is 3x. Therefore, x is y plus 1 over 3. So, therefore, inverse of x. X was 1 over 3. So then you invert it. So there you go. You don't need to write anything else. You could say as x and y are reflected. So it doesn't matter. But that's your function. Okay, so the y and the x's change places, essentially. And you do that by rearranging. And there you are. Okay. So we have given that fg of x is 2g of x. So you have to remember, this is what I don't like, this notation, especially when you get to university or even A level, they give it a different way. This is not the same as times in the functions. It's not the same. And the reason why, if you wanted to show times in, you'd write it as f of x, g of x, not f of g of x. Because what this is saying, is there's missing brackets here, so it should really be f of g of x. There's missing brackets here for f. That's what f g of x is saying, okay? Not your times in them. Okay, just to be clear, I don't like the notation. I'm going, but that's what that means. So f g of x is f of g of x, and likewise g f of x is g of f of x. So we are told f of g of x is 2g 2 well, actually no. We are told f of g of x, the composition, these are composite functions. F of g of x is 2 lots of g of f of x. So actually, let's find these two expressions. What's f of g of x? First of all, well, that's f of, and substitute g of x in. Okay, now g of x is x squared plus 4, and then substitute f of x squared plus 4. So wherever there is an x in f of x, there's 3 lots of x, where instead of x, you replace it with x squared plus 4 minus 1. And so expand the bracket, you get 3x squared plus 12 minus 1, which is 3x squared plus 11. And likewise, g of f of x is g of 3x minus 1. That's f of x, right? F of x is 3x minus 1. And so then substitute 3x minus 1 into g. So g is x squared plus 4. So instead of x squared, in place of x, this is 3x minus 1 squared plus 4. Yeah. And then again, just expand and simplify. That will go to 9x squared minus 6x minus 1 plus 4. Again, if you're unsure of the brackets, be careful. Do it like this. If you're squaring a bracket, it's the same as repeating and multiplying by itself. Okay, that's what that means. And then do the FOIL method or whatever method you prefer. So that'd be 9x squared minus 3x minus another 3x plus 1, which goes to 9x squared minus 6x minus 1, which we've got here. Okay, so that's where that comes from. But obviously, if you're a bit more confident with it, you can skip that. But that's where that comes from. And that obviously then simplifies to 9x squared minus 6x, 4 minus 1 plus 3. Now it's saying that this is 2 lots of this. So f of g of x is 2 lots of this. So that means 3x squared plus 11 is 2 of 9x squared minus 6x plus 3. So 3x squared plus 11, not going to have much room for this, is 18x squared minus 12x plus 6. And actually then bring the x squared. I think it's best to bring the x squared on here because it's make it positive. So 15x squared, if you subtract 3x squared to both sides. And then minus 12x. And then minus 11 to both sides. That's 6 minus 11. And we've gone wrong somewhere. Because that should be minus 1 apparently. So where have we gone wrong here? 11. Oh no, it's plus 1. Sorry, plus 1 here. Yeah, so that would be plus 5. My apologies. So that would be 2 of 9x squared minus 6x plus 5, not plus 3. So that'll go to plus 10, not plus 6. So then 18, so minus 3x squared, yeah, and then 10 minus 11, which goes to minus 1 equals 0. And the reason I knew there was an error, well, partially is because of this. I'll need it to be matching this, and we get this exact answer then. So we know we've done it right. So there we are. Yeah. And that is why, that's also a good example for why you check with expanding the brackets. So again, probably got a bit ahead of myself then. I put a minus and a positive. But anyway, we got there in the end. So that's how you approach that question, and that's how functions are really. Just use the notation to help you. So once you realise this, it should be a doddle. You should know what it should guide. You should know what to substitute or where to substitute into. G of x is this whole thing here. So just substitute it into the brackets and stuff like that. That's all I mean. That's what it means. I I don't think the maths here is particularly too hard. I don't think. You just got to realize. You've just got to understand how functions work, which hopefully you should have practiced by now. This is again a very standardish question. Not too bad at all. Oh, we're on the final question now. Okay. On the final question, again, obviously, it's going to be longer than obviously hour and a half or however long for the paper because obviously we're going over it and stuff like that. So it's going to take longer to explain things. But anyway, on the final question now. So it's a probability one. How's it interesting? The first question was the probability one, and the final one is interesting. Anyway, there are only red counters and green counters, and it gives us the variables here. So there's probably going to be some algebra involved, because we're giving us letters. So it's only red and green. The counter is taken random from the bag. The probability is 3 over 7. The counter is put back in the bag. So this is screaming tree diagrams, right? So it's going to look like this. That's what's screaming. So the probability. So there's green and red. Then a counter is taken. And so then the probability, the counter is green, and then it's red, and so forth. The counters put back in the bag. 2 more red counters, and 3 more green counters are put in the bag. The counter is taken at random from the bag. So then there's another situation going on. So one counter is taken. So this is counter 1, and this is counter 2. Anyway, so it's going to be a tree diagram. When you got a situation like this, where stuff is being taken from a bag and they want you to deal with probabilities, it's tree diagrams, okay? So let's draw it. So what's going on there is so there's 2 counters being taken, right? 2 different counters. Counter 1. So that's simply going to be, we are told it's only red and green. So the probability of taking a red counter is going, well, there are red counters, and in total, it's R plus green, right? R plus G. That's the total out of count of the first bag, right? And likewise with green, obviously out of G green counters, out of the combination of red and green. That's the first count. So if I pick a counter, those are the probabilities. Remember, probabilities of say of picking a red counter is number of red. And again, this is very, very similar. It's not the first question, but you just add in a bit of algebra in. That's all it is, really. Number of red counters over total number of counters. Now, obviously, there are R red counters, so that's going to be R. The total is going to be R plus green, because that's how many there are in total. Green and red, R plus G. So that's where this comes from. So as long as you understand what a probability means, this shouldn't be too bad. But anyway, So let's fill this diagram up. It tells us also the probability the counter is green here is 3/7. So this means G over R plus G is 3/7. There's not much we can do here because uh, there's two variables. You can't just solve for one of them. So we're going to leave that there. We're going to need something else probably. But then it tells us about another counter being taken. So the counter after this is put back in the bag. So the total is going to be R plus G again. So the counter's put back in the bag. Two more red counters and two more green counters are put in the bag. The probability that the counter is green is 6/13. So actually, it's kind of like a disconnected tree diagram. You don't pick, you're not picking two counters actually, one after the other. It's basically two different situations. So you pick a red counter, and then a green counter, and then you kind of like ignore it, and then you pick the other counter after this, but you don't like times it. They're not like one after the other, if you know what I mean, because the counter's put back in the bag, and it's because it says the probability the counter is green in the second instance. I don't know if I explained it well, but anyway, in the second counter, anyway, all the counters are back in the bag. So when we do pick the second counter, it tells us there's two more red counters and three more green. So the total now is going to be R plus 2 plus G plus 3. Because there's red counters and two more, and green counters and three more. So it's going to be R plus G plus 5. So the total is that this time. However, so the probability of taking a red counter now is going to be R plus 2, because there's now R plus 2 red counters over R plus G plus 5. Likewise with green, there are three more green counters. So it's G plus 3 green counters to choose from over R plus G plus 5. And it also tells us that in this probability here, G plus 3 over red R over these are two different ones. R plus G plus 5 is 6/13. Okay. And actually now it is kind of like two simultaneous equations, two variables and two unknowns with two equations. So what we've got to do now is essentially solve them. But obviously it's not going to be the nicest, is it? I might need to make some room here actually. You don't really need a tree diagram actually. I thought I thought you might do, but you kind of do. But it's not a tree diagram example. You're not picking one and then picking another one. They don't affect each other. It's two different situations. Is what I'm getting at. Like you don't pick one and then pick the other and then branch it off like this. It's just two disconnected different situations. So they're separate. So you don't really need you could just ignore that really. Um, okay. So now we're just solving this. So what is algebraic fractions? If we have g is 3/7 times across, so 7g. We're solving this one first. Is 3 lots of r plus g. Expand this is 3r plus 3g. Let's bring g in terms of r. So subtract 3g to both sides. 4g is 3r. So that means, um, oh god, there we go, 3r. Subtract 3g, 7g minus 3g is 4g. And then put g on its own. 3/4 lots of r divided by 4. And that's 1. So now what we can do is we can substitute it into this. So now we can say, therefore, g plus 3 is and I should say that's r as well to clarify. 3 over 4r plus 3 over r plus 3 over 4r, because remember, g is replaced with this now, plus 5 is equal to 6 over 13. And now actually we can simplify this. So 3, a little bit, just a little bit. So 3 over 4r plus 3. But these we can collect like terms. So r plus 3 over 4r, that's the same as saying 1r plus 3 over 4r, which is 1 plus 3 over 4. Now that is 4 over 4 plus 3 over 4, which is 7 over 4. So 7 over 4r plus 5 is equal to 6 over 13. Cool. And then like exactly like this with algebraic fractions, cross multiply. So I'm going to need more room here. Let's get rid of this. That's equal to 6 over 13 still. Okay, so then times across, so 13 lots of 3 over 4r plus 3 is 6 lots of 7 over 4r plus 5. And so yeah, so then expand. 30 times 3 is 39 over 4r plus 39. 3 times 13 is 39. And that equals 7 over 4 times 6. 7 times 6 is 42. 42 over 4 r plus 5 times 6, which is 30. And so it's a linear equation. So r, I mean, it's not a nice one, but let's bring it over here. Let's get rid of this so I'm not confusing people. So bring it down here. So then bring the r's to both sides. So 39 over 4r minus 42 over 42 over 4r. That's going to be equal to 30 minus 39. Okay. That's plus 39. That's a plus 30. So r's on this side on the left. So minus 42 over 4 to bring it over here. And then bring the constant over here. So 30 minus 39. Okay, that's obviously going to equal minus 9. So now we're going to deal with this fraction. Well, 39 over 4 minus 4, well, they're the same denominator, aren't they? So you could just simply minus the numerator. So 39 minus 42 is minus 3 over 4r. And so actually r is going to be, you can divide by minus 1 then to get rid of the negatives. So then r is going to be 4 over 3 times 9. And you can see this because we're dividing. Let's just really clearly see what's going on here. 3 over 4r is minus 9. Divide by minus 1 to both sides, get rid of the negative. 3 over 4r, and that's r, not 1, is 9. Then you want to divide by 3 over 4 on both sides. So then you get r is 9 divided by 3 over 4. Now, KFC again. 9 divided by 3 over 4 is the same as saying 9 times 4 over 3, which is where this comes from here. Okay. So break it down if you're a bit unsure, if you're a bit unconfident with the arithmetic and stuff like that. That's all we're doing is how we've gone from, just to clarify, from this step here to here. We got rid of the negative, divide by minus 1, and then divide by 3 over 4 on both sides. So that's the same as saying 9 divided by 3 over 4 is times 9 times 4 over 3. Now, actually, this the 9 and the 3 cancel. So 9 divided by 3 is 3. So 3 times 4, which is 12. So 4 times 9 is 36. Hang on. Yeah, not 4 times 9 is 36. Divide by 3 is 12. So that's where that that's where that comes from if you do the multiplication. So that's telling you R is 12, which means red for R is 12. So R is number red counted originally, which is 12. So therefore we also know this. If you remember all of this, G is 3 over 4R. So that means G is 3 over 4 times 12. Uh, and so obviously notes again, 4 and the 12 cancel. So 12 over 4 is 3. So 3 times 3, which is 9. So G, which is the number of green counted in the bag originally, is 9. Again, spot this. 3 times 12 is 36. Divided by 4 is 9. So that's where that comes from. So that's your answer here. Okay. Yeah, so it's an interesting question. It really is. This question really tests your algebra skills. This is for those grade 9 students. It really is. It really tests if you know your algebra. If you want a good test of your algebra skills, this question is a good one to do. I really like that. I really do like this question actually. So probably it feels like the first question, but you just thrown some hard algebra into it. Because remember the first question, we have to find like probabilities, but they give you all the numbers. But this one, it's got loads of unknowns. Compare that with the first question. But I really like this one. Obviously, probably a lot of people don't, but I do. But that's how you'd approach this one. Don't be afraid to just visualize it like I did with the trees. What's going on in the first count? When you pick the first counter, it's either green or red. What are the probabilities? And then when you pick the second counter, what are the uh, what are the probabilities there? Right. So actually, I'll write that again. Actually, red, green. In the first counter, there are R. So the total is red plus green, R plus G. And then the second one, and then for green, obviously green counters out of red plus green. And then the second one, it's telling us there are 2 more red counters, so R plus 2, plus 3 more green, so green plus 3. Well, actually, that goes to R plus G plus 5. And so the number of red now counters is red plus 2, R plus 2 for red. And the green is going to be G plus 3, because now there's 3 more green counters. So that's what's going on, plus 5. So that's what's going on here. So then it's saying that this probability, the first one, is 3 over 7. That equate this to 3 over 7, which we've done here. Green plus red plus green is 3 over 7. And then the second probability, in the second instance, the probability that this is green, so this represents green in the second counter, is G plus 3 over R plus G plus 5. And that equals, what is it, 6 over 13. And so what you're doing is solving them equation, and that's what happens. So once you found those probabilities, you then do algebra to then solve for G and R, and that's what this question is doing. Okay, so that's the run for the last question. Okay, cool. So that's it. That's a run through. I guess the main, obviously, any questions, shout at me. But the main question I do want to the main point I want to home in on is the fact that a lot of these are similar questions every year. And, a lot of these are the same topics, slightly worded differently. A bit, some of them might be a little bit different, but the topics are reoccurring. Let me just go over this again from question one. Let's go. Because I did the 2018 paper yesterday. Let's compare which topics are the same on both papers, which come up twice. Uh, there was a probability one, not like this, but there was a probability one, and both of them. Uh, there was a ratio question like this, like this. Uh, there wasn't highest common factor one, but that's likely to come up. There is going to be a HCF or lowest common multiple question on your paper, definitely. Um, there was one like this, exactly like this. But where one you have to deal with plans and elevations and the sketch of the shape that came up. That translations and all this transformations that was on both the papers. Exactly, very similar. A ratio question like this. You have three different three numbers, exactly like this, exactly like this. That was on there. This was there wasn't a question like this, but again, I predict something like this will come up. Estimation came up, index laws came up here. That came up on both papers. Fractions, very similar, came up on the other paper too. This didn't, although that's only 2 marks. So. Yes, box plots came up. So this is God, what a mess this is. Box plots came up, but obviously this is just talking about. This doesn't give you the box plot, but it gives you the. It wants you to calculate it instead of showing you it. So obviously a box plot is the median, the quartiles, and the min and the max. It's the same sort of question, but it's presented in a different way. Okay, so it's a similar sort of question came up in both of them again. Yeah, PQ. Yes. Yes. So, I was going to talk about this, wasn't I? The ratio, fraction. Yeah. So remember when we talked about the algebra fraction? What was it? X squared to what? What was it? X plus 4. Was it the same as 1 to 2? It's a very similar principle. So, uh, P to R. Okay. Well, with P to R, actually, I'm going to do it here. It's this little document here. So P to R is said to be, what was it? 4 to 9. The way if you have if you're given two ratios like this are equal, this approach will always work like it did with the other question. You want to make a common number in both of them. So the best way to do this is to make it 1. Make the ratios look 1 to n on both of them. So the best way to do it, let's make both of the left ones 1. So divide by p on this one. So you get 1 is the same as r over p. That's the same as r divided by p. And then with this one, divide by 4. So then you're left with 1 over 9 over 4. So now you can directly compare them. Obviously, 1 equals 1, and then that means r over p has to be 9 over 4. And then you can say, cross multiply, 9p is 4r. So that means p has to be 4 over 9r. And that is where that comes from. To get p is 4 over 9r there. Okay. So that's why you jump straight from there to saying p is 4 over 9r. Okay. This is why you could jump to saying, oh God, if you have this ratio p to r is 4 to 9, this means p is 4 over 9r. This is what's going on. Okay. A little sketch, a little derivation, a little proof almost behind this. Okay. And if you're like me, this who's a bit unclear, this is the step you can take. So if you have two equal ratios, and especially go do those algebra questions like the other one, you make the two ratios have the same number, because what that means then is you can equate them exactly. Okay, so if the two numbers are the same, then all numbers have to be the same. So that means if one is on the either side, that means this number has to be the same as this. So r over p has to be 9 over 4. And then obviously you can then show that p 4 over 9r by cross multiplying. Okay, so I did explain that then. Okay, in the end. But that's where that comes from. But yeah, there was a ratio question as well. There was a lot of ratio questions on the other paper. An algebra proof question came up. A trig one didn't come up, but I highly predict there will be a trig question on your paper. Because it's the only paper that can assess it. Because obviously, if a calculator, you can just plug the values in. This is strictly a non-calculator question. And specifically, if you want to remember trig ratios, exact trig fact, I do have a video on that, as I said, on my channel, to help remember of that. Obviously, if you have your own way, that's great. Stick with that. Okay. Okay. Volume thing didn't really come up. This didn't really come up either. Okay, yeah, this I predict will come up. Maybe not in the non-calculator, but there would definitely. I've seen it on like every single paper. There was an algebra fraction question, so you have to convert this into a fraction and then solve it. So make sure you know how to do that. It is free. I think if you're comfortable with solving algebraic fractions, it is easy marks, as long as you can convert the ratio here into an equation like I've done here. So exactly the same process as I've just shown. Make sure that both have the same number. So I picked 1. So divide by x squared here to get 1 of 3x plus 5 over x squared. Divide by x squared. So 1 of something is 1 over 2. So that means this fraction has to be 2 for this to work. And then you solve it as follows. And yeah, so that's how you approach that. And all algebra fraction questions. Surge came up. Surge came up on the paper. Complete the square. I don't think so. Direct inverse proportion did. Very, very identical, very similar, almost identical question. The method was exactly the same, just different numbers and stuff, really. Function didn't come up. Yeah, a bit of probability. Okay, but the point I'm making is, well, probably I'd say over half the paper was pretty similar, right? Half the paper had stuff in common, like, um, so the point I'm making there is practice papers. 'Cause not only are you practicing all the topics and getting experience and know what a paper looks like, and you know exam technique, it also helps you prepare for your paper because there's going to be very similar questions to the other papers and other topics. And yeah, past papers is your best resource for maths. It really is. Practice, practice, practice. And what's better practicing than the real thing, right? The actual past papers they've asked before. Anyway, so I'm going to stop rambling now. I'm going to leave that there. So that's the 2019 June paper that I walked through. Um, uh, yeah, this will be on my channel. It'll be obviously it'll be in the GCSE Maths past paper video. And that's the aim of what I'm doing. I'm going to go over certain papers if I have time, obviously, as much as I can. Perhaps even make some videos on certain topics. Obviously, let me know. Ultimately, it's down to what people struggle with, what they want help with. That's what I'm here for. So if there are any topics or questions or videos you want in particular, any particular question or on a paper or whatever that you may think might help, ask away. I'll try the best I can to help with any questions you have. And also, even let me know if something's gone wrong. If I've gone wrong as well, let me know. That's also good as well. If you can spot where someone's gone wrong, that's a very good skill to have as well. But yeah, hopefully that should be right. Hopefully I've done the right thing. But anyway, that's the aim of this. Obviously, obviously got a paper on Thursday. I'll probably do another video stream on Wednesday. Probably another past paper. But obviously, if someone comments, "Oh, can you do video or can you go over the XYZ topic?" Sure. But yeah, I'm gonna leave that there then for now. So yeah, that's it for this stream, this video. So thank you for watching. Obviously, ask anything if you have any questions. But yeah, see you next.